Hey there, mathematicians. It's Miss Johnson, and today we're going to be looking at theoretical and experimental probability. So theoretical probability is the probability that we've already talked about. It's the number of desired outcomes out of the total number of outcomes. Experimental probability is similar to that, except an experiment is actually happened. So, let's say that we flip a coin and we flip it 50 times. Well, how many times did we flip it and it came up heads? So that's the number of times an event occurs. And then the total number of trials, or the number of times that we did the activity, we would flip the coin 50 times. So the bottom number would be 50. So experimental probability is a little bit different because an experiment is actually completed, whereas theoretical is what should happen in theory. Okay, so theoretical probability is based on theory, what's supposed to happen. Most of the time they just ask you what is the probability. They might ask you what is the theoretical probability, but most of the time they just say what is the probability. And if it's theoretical probability, an experiment is not actually done. But if we're doing experimental probability, an experiment is performed. Examples of that would be like dice are actually rolled, a coin is actually flipped, spinner is actually spun, and the results are recorded. If you're given a question about experimental probability, they will have to give you the results of the experiment. They have to give you the results of the experiment. Otherwise, you can't answer the question. Sometimes you'll have to find the total number of times the experiment is done, and you just add to get the total. And they will have to ask you what is the experimental probability. They'll have to put that in there, or they might say using the experiment, what is the probability? That word experiment will have to be in there somewhere. Okay, so let's do an example. So if we flip a coin, the theoretical probability of flipping a coin, of getting heads, is one head out of two things that can happen, right? You can get heads or tails. So the probability is 1 to 2, or 1/2, which is 50%. And then the probability of tails is the same. It's 1 out of 2, or 50%. So we're actually going to do an experiment where we actually flip a coin. Okay, so bear with me. I'm going to have to switch screens a little bit. Okay, so here we have our coin. And we are going to do some random flips. Now I need to record it, so I'm going to have to go back and forth. I tried to split the screen, but it wouldn't work. So, okay, so we have heads, tails, and tails. So heads, tails, tails. And I have to go back and forth because I don't have a great memory. Okay, so we had heads, tails, tails. So we're going to flip 10 times. Okay, so we've already done it 3 times. Heads, heads, heads. Oh, that was easy. Let's do one more. Heads, 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 and tails. So 3 heads and the tails. So 1, 2, 3, 1 tail. So that's 7. So we need 3 more. Okay, so heads, tails, heads, heads, tails, heads, heads, tails, heads. Okay, so we flip 10 times, so we have 6 heads and 4 tails. 6 plus 4 is 10, so we did 10 flips. So our experimental probability, so the probability that we got when we flipped the coin for heads was 6 out of 10, which is 60%. And of course, we would need to simplify this. So it would be 3 to 5, which is 60%. And then the probability of the tails was 4 out of 10, which is 40%. And if we simplify it, it would be to 4/5. So you can see that the experimental probability and the theoretical probability did not end up being the same here. And when we have a small number of experiments, like we only did 10 flips, we didn't do that many. When we have a small number of experiments, the theoretical and the experimental probability are not going to be close together. But if, say, we did this 1,000 times, the probabilities would be closer together. The theoretical probability and the experimental probability would be closer together. Okay, so we're going to spin a spinner. And again, I'm going to flip to a different screen so that we can do this experiment. We're going to do it 25 times. Okay, so it's this one, but it's not. It's this one right here. So we have a spinner. It has, I want to do 5 sections. It has 5 sections. Notice that the 5 sections are equal sized. So that's important, because if they were not equal sized, you would need to make them equal size in order to figure out the probability. So we said we're going to spin 25 times. Not 12 times, 25 times. Okay, and we're going to see what happens. Notice they already have the theoretical probability there, because the probability of landing on any of the colors is 1 out of 5, and 1/5 is 20%. Okay, so they have that theoretical percent there. Notice it is not going to change as we spin. Okay, and this is cool because it's just going to spin. I don't have to do anything. And it's going to start recording. So we got 1 red, so that was 100%. Notice it's changing as we go. We only spun twice, so it's 50-50. We spun 3 times. 4 times, it's going to be 25, 25, 50. And it's going to keep going. And as we spin and get the color, the experimental percentage is going to change because we're getting a different color each time. Man, purple is coming up a lot, isn't it? All right, notice the more that we do, the closer it's going to get. Okay, I'm just going to go ahead. I don't know how many it's done. Does it tell us? No, it doesn't tell us. I'm going to go ahead and skip to the end. Okay, so blue came up. Wait, let me do the second right on it. I forgot you can do this. Oh, it's not going to do it because I'm doing the... Oh, it did do it. Thought it might not do it because I was doing the screen record. Okay, so we have... If we look here, this gives us our count, right? If we add those up, the total is going to be how many spins we had, which was 25. When we add these up, our total should be 100%, just like our total here should be 100%, because all the things that happen should add up to 100%. Okay? All right, they have the 36 highlighted because that was the highest percent was red. Okay, so let's see if I can remember this. 12, 28, 36, 24. 12, 28, 36, 24. I'm probably not going to remember it. Probably going to have to come back to it. So it was 12. See, I already forgot. 12%. 12, 20. So 28, 36, 24. 28. 36 and 24%. So I wasn't able to see how many times each one was done because it automatically switches to percent. But notice that some, like red was only 20%, but it ended up 30%. Purple was only 20%, but it was 24%. So remember, the experimental probability is going to be different than the theoretical, but the more that you do, the the closer it should get. All right, let me reset this and let's do, instead of doing 25, let's do 250. Okay, and we spin it, and then we're just going to skip to the end because we're not going to watch this go 250 times. Notice that it's getting closer, right? It's getting closer to the theoretical. So the experiment was, for blue, the experimental was 17.2%, which is close to 20%. The yellow was 19.6%, which was close to 20%. So you see how they're all getting closer to the 20%. So the more you do an experiment, the closer and closer the probability should get to the theoretical. If it doesn't, you might not be using a fair device. All right, so differences between theoretical and experimental probability. Your theoretical, it's what should happen, right? You're just looking at your whatever is happening and you're saying, okay, this is what I want. This is how many different things that can happen. That's the probability. When you do the experimental probability, you actually do an experiment. That's the difference between experimental and theoretical.